Okay guys, so I'm going to help you get started on this little worksheet here. Alright, so it says, suppose you want to find the area underneath the curve below. One way to do this is by approximating its area using rectangles. So there's some key words in that sentence. We're approximating, which means we're not going to get the exact area, but we're going to get a close guess. And we're going to do it using rectangles. Okay? So those are two key words to focus on there. We're going to estimate the area under this curve below using the rectangles that I've drawn here and the fact that the equation of the curve is y equals 4 minus x squared. That's the part that's not obvious and people miss it, so make sure you got that. And we're going from 0 to 2. So remember, we're trying to find the area underneath this curve on the interval from x equals 0 to x equals 2. So that would be this region I'm shading. And as you guys can see on this first one here, we're going to be approximating the area using rectangles, and it's going to end up being a little bit more than what the real area is because the rectangles are higher than the space we want. So why are we doing this with rectangles? Well, we know how to find the area of a rectangle, don't we? It's base times height. So, for instance, what's the base of this rectangle here? It's 0.5. And what's the height? It's 4. Base times height gives me a total area of 2. So that tall rectangle there has an area of 2. All right? I'm going to skip the middle one for now, and I'll tell you why. The reason why is because we don't know the height yet, but I'll tell you in a second. For now, let's go to this next one. This next one's pretty easy. We can find this area. What's the height? The height is 3. The base is, once again, from 1 to 1.5 is 0.5. So 0.5 times 3, what would that be? That would be 1.5, right? So those two are pretty easy. The other two rectangles that we're looking at there, the problem is we don't know the height. And that's why the equation that I gave you guys earlier is important to have. So that equation represents this line. I want to know how tall is this rectangle. Now, if I know the y value for this point, that's the height of that point, which is the height of my rectangle, right? Well, I can find the y value if I know the x value, and guess what? I do. The x value is 0.5. So if I just plug in 0.5, I can find the y. Let's do that. 0.5 squared is 0.25, and 4 minus 0.25 is 3.75. So my height of my rectangle is 3.75. The base from 0.5 to 1 is 0.5. And now I can do base times height like I was before. I'm a little out of my league now with just mental math, so I'm going to have to use a calculator. 3.75 times 0.5 is 1.875. So the area of this rectangle now is 1.875. We have one more rectangle to do. So I've got this area, I've got this area, I've got this area, and I need to find this area. Once I have all four, I'm just going to add them together. And that's going to be my estimation for the area underneath of this curve. And as we would expect, it's going to be a little bit extra because it's a little bit higher than the curve. But it's close, right? We're getting an estimate. Now for this one, I want to know what's the height of this rectangle. And once again, I don't know what it is. So I need to know the coordinates of that point right there, another x and y pair. And once again, you can find the y, which is the height of the rectangle, if you have an x. And sure enough, the x for that point is 1.5. Excuse me. All right. So we're going to repeat this process up here, but this time I'm going to plug in 1.5 to find the y value for that point. So y equals 4 minus 1.5 squared, and 1.5 squared would be 2.25. 4 take away 2.25, I believe, would be 1.75 is my y value. So that means the y value of that point is 1.75, which means the height of this rectangle is 1.75. So we have another base of 0.5 times another height of 1.75. Let's do it. 1.75 times 0.5 is 0.875. Okay, so I got a lot of extra stuff up here, so I'm going to erase all the extra stuff that I've got. All right, so this rectangle's area is 0.875. So I've got 4 rectangles here, and I found all the areas. So now if I want to find the total area under the curve, we just add it all up, right? So I'm going to do 2 plus 1.875 plus 1.5 plus 0.875. So here we go. 2 plus 0.875 plus 1.5 plus 0.875 equals 6.25. So the area under this curve is approximately 6.75. Okay? So that's how you do number 1. I'm going to let you guys do the other 2. Okay? So this is an overestimation because all of my rectangles are higher than the actual curve. Over here in number 2, it's an underestimation because I made the rectangles go under the curve. So once again, you need to find your y values for these points because those points are the heights of those rectangles, which we need if we're going to find the area. So my answer over here is 6.75. You guys are going to get some smaller number over here when you do yours, and we know that the real area is somewhere in between there, right? So that's one way we can estimate the area underneath of that curve. Number 3, we're talking about a better approximation because if we use more rectangles, as you can see, the amount of space that is unaccounted for decreases. So, and I didn't put the x values here, but you guys, maybe you can figure them out, but I'll write them if you can't. Those are the x values. You're going to need those once again to get your y values for the heights of those rectangles. Okay. Let's see, number 4. So I'll let you guys ponder that. But don't forget, though, that's the end of that. Then we switch gears completely. Actually, we're not switching gears. You don't realize it yet, but this is actually, these 2 ideas are closely linked. But in part 2, you're not going to see the connection yet. But part 2, your job is to work backwards, basically. I tell you the derivative, and then I ask you what's the original function. So I'm going to let you guys figure those ones out. I think you guys can just brain power your way through that. But the first one I just wanted to go over with you. So I hope that helps, and we'll see you guys in class tomorrow.